I'm going to draw a free body diagram for the box. So first thing is, notice that the weight is already given. It's in newtons, so you do not need to multiply by 9.8. A lot of you already caught that, which is good. Then we have the tension force this way equal to 60 newtons at 60 degrees to the floor. And then we're going to have some kind of normal force. And we'll address that in a second. And then there's also going to be kinetic friction pulling back. Now, we learned about components at the beginning of chapter 5 because we wanted to work with all forces on the x direction and the y direction. And this one is not that. So what we need to do is resolve the tension into an x component and a y component. And so you're going to do your triangles. 60 cosine 60 is going to give you x, which is 30 newtons. And 60 sine 60 is going to give you y, which is 52 newtons. So by doing that, we effectively have removed this tension from our free body diagram. So if I were to redraw the free body diagram, you don't have to do that. I just want to do this for illustration purposes. We would have Fg equal to 100 newtons. Tx to the right is 30. Friction to the left is unknown. Ty is 52. And then our normal force has to make up the difference between 150 and 52. So if you have 100 newtons down, and you're in equilibrium with respect to the y direction, that means that your normal force is going to be 52 newtons less than 100, or 48 newtons. Okay, so those are our three forces in the y direction, and the y is in equilibrium. So to get the acceleration of the box, we know we're going to need to use Newton's second law. So let's write that out. Newton's second law, F equals ma. We're only going to worry about the x direction. So we're going to have tension in the x plus kinetic friction equals ma. Tension is 30. We don't know the friction. The mass is going to be, remember that Fg is mg, and we're told that the weight is 100 newtons. So you're going to do your mass times 9.8, and then you get your mass is 10.2 kilograms. So that's your mass, 10.2, and then we want to find A ultimately. So there must be a way to get your kinetic friction, and that's what we learned here in chapter 5. So we can get the kinetic friction using our coefficient and the normal force. So the coefficient of kinetic friction, mu kFn, is 0.430 times 48. So 48 newtons. So you get 21.6, or 20.6, we'll round it to 21 newtons for your kinetic friction. So now that will go in your Newton's second law equation, so now I'm going to put that there. Negative 21. Negative because it's to the left. And now you could solve for A. So you got 9 divided by 10.2 basically. And A is 0.92 meters per second squared. So that's what we needed.